Hello, welcome to another video. This is an infinite series problem and you're supposed to find the interval of convergence. In order to do that, we will need to know where the center of convergence is. We need to know what the radius of convergence is, and we know that the interval is basically how far you can go away either to the left or to the right from the center, depending on what the radius is. So let's set a template for what we're going to do. Basically, we have this. Let's assume this is the center of convergence, and you can directly read the center of convergence from the problem you're given because it's always the number here. Now, if there was nothing here, if it was just x to the n, then you have to read it as x minus 0 so that your center of convergence is 0. So right now, our center of convergence is 1. Okay, now how far can we go from 1 such that these infinite series will still converge? What values of x can you use? Because if this x becomes too large, then it will no longer converge, and whatever you're getting will not be accurate or will not be as accurate as you want. So what you have here is a radius. So we're going to calculate this radius. Okay, so this is plus the radius, this is minus the radius. We're going to find what this is eventually. And then the maximum distance you move away from here is your interval of convergence on the left. And here, is your boundary of convergence, and you have the upper boundary of convergence also. Now, sometimes you may include the boundary, sometimes you exclude the boundary, depending on what the boundary conditions are. So now, how do you get your R? Firstly, we have to do the ratio test. So the ratio test helps us find a value. I'm just going to call it L, which is the limit of the ratio of a term to the preceding term. So we're going to have L. So L will be the limit as n goes to infinity of a sub n plus 1 over a sub n. That is, you take the next term and you divide it by the previous term. Now, what should you use as your a sub n plus 1 and your a sub n? I've seen many people include this term here, but it doesn't matter because at the end of the day, what's important is you getting what L is. So, and your final presentation is going to look like this, and you want to make sure that the absolute value of L multiplied by what you have here, x minus 1, is less than 1. Okay, this is the presentation. Now, what do you need L to be itself? You generally would be happy if L is less than 1, because that way you know that this will converge. Absolutely. So it will give you absolute convergence if L is less than 1. Now, if L is greater than 1, it's going to be divergent. Okay? And if L is equal to 1, you cannot make any decision. So what you're always looking for, if you're looking for radius or interval of convergence, is that the value you get for L will be less than 1. So let's write, we want L to be less than 1. And then we can come back and use it here. But let's go find what L is. Okay, so what is a sub n plus 1? So we're going to say L will be the limit as n goes to infinity of a sub n plus 1 will be the version of this where you have increased this by 1. So it's going to be negative 1. This is the absolute value of negative 1 raised to n plus 1. Okay, divided by, you write this also, that's going to be 2 times n plus 1 minus 1. Okay, all multiplied by 2 to the n plus 1. And you're going to divide it by a sub n. A sub n is now what you have here. And remember, when you're dividing a fraction by a fraction, you flip the fraction on the right. So we're going to flip this one, and we're going to get multiplied by 2n minus 1 multiplied by 2 to the n over, then we'll write this, negative 1 raised to power n. Okay. So the rest of this is all simplification. Now, what should you do? Well, we know that this can be rewritten as, let me go this way. Okay, so I can save time. This is the limit as n goes to infinity of, now watch, I'm going to write negative 1 raised to power n times negative 1 Okay, I'm going to combine everything on top. Just write it. Then this is going to be 2n minus 1 times 2 to the n. Okay, all divided by, the bottom part is going to be, this is 2n plus 2 minus 1. So 2n plus 2 minus 1 is going to be 2n plus 1. So this expression gives me 2n plus 1, 2n plus 1. And this gives me 2 to the n times 2. I have 2 coming from here. And then this is negative 1 to the n. Perfect. So all we have to do now is cancel every term that we can cancel. I know 2 to the n can be canceled. I know negative 1 to the n can be canceled. What else can we cancel? It doesn't look promising. Looks like we are stuck with what we have here. So the limit as n goes to infinity of, now let's simplify the top expression. It's going to be negative 2n plus 1. So we have negative 2n plus 1 is what's on top. And under we have 4n plus 2. If we multiply this, we have 4n plus 2. Okay, so that's the major part, actually. That's the toughest part of all of this. Maybe not the toughest, but the second toughest part. Okay, now, okay, you know how to take limits. Negative 2 over 4, absolute value, which will be 1/2. So the essence of the absolute value is we're looking for a distance. We don't care about the sign. That's why we're checking about, we're putting the absolute value signs around the expression. So we got 1/2. Our L is 1/2. Remember, we were seeking L to be less than 1. So with this, we could clearly tell that this is absolutely convergent. So we can say this series is absolutely convergent. So what should you do with the answer you just got now that you know it is convergent? You just want to go back to this part that I said initially, okay? I didn't have to write it this way, but because I already took care of the absolute value. But let's say you put everything together, because some people like repeating this. What you can do is pull out the L and leave the absolute value for x minus 1. So I can write it this way. 1/2 of the absolute value, let's say therefore, 1/2 of the absolute value of x minus 1 is less than 1. Do you see that? Now we can get rid of this 1/2 here by dividing both sides by 1/2 or multiplying both sides by 2. Well, the sign doesn't change because there's no negative sign. We already took care of the negative sign in the previous part. So here, this implies that x minus 1, the absolute value, is less than, if you multiply everything by 2, you're going to end up with 2 here. Now, guess what? You see this number you got? This is the radius of convergence. Okay? This is the radius of convergence. So, radius of this is the radius of convergence. Radius. Okay? The radius of convergence is actually the reciprocal of L. The reciprocal of L. So once you get this, you know, if you flip it, whatever you get when you flip it is the radius of convergence. So that means if what you got was 0, then your radius of convergence will be infinity, right? It means that it converges everywhere. But right now, it does not converge everywhere. You can't go beyond 2. You have to stay within a radius of 2 from the center. Now, what did we say the center was again? Okay, brilliant. So you can come here and add 2 to 1, you got 3. Subtract 2 from 1, you got -1. This is our expected interval of convergence. So, but we're not sure if we're going to take the end point. But for now, we can say we now have a likely interval of convergence, which is from -1 less than x and x less than 3. Okay? Some people like to use the absolute value thing. You know what? If you just start with this, you will be fine. You see, this expression, absolute value of x minus 1 is less than 2 can easily be rewritten. If you remove the absolute value signs, it becomes negative 2 is less than x minus 1 and it's less than 2. Now, if you add 1 to each of the terms, if you add 1 to this, you get negative 1. You add 1 to this, you get x. You add 1 to this, you get 3, which gives you this same interval that I just wrote. Now, can we take this as the interval? Can x be 3, or can it, does it have to be strictly less than 3? Now we need to test. So we test when x equals negative 1, what's going to happen? If we have this negative 1 for the value of x, let's put negative 1 here. Say negative 1 minus 1 will give you negative 2 raised to power n. Okay? Negative 2 raised to power n times negative 1 raised to power n. What do you get? Okay, let's do the work. I'll get rid of it when I'm done. So look, so you're going to have negative 1 raised to power n times negative 2 raised to power n divided by 2n minus 1 times 2 to the n. That's what you get. Notice that from your law of exponents, you can combine these two and then you get 2 raised to power n. So this basically is 2 raised to power n divided by 2n minus 1 over 2 to the n. And these two will cancel out so that you end up with 1 over 2n minus 1. Now, what do you think this is? So let's say we sum this up, okay, to infinity. Do you think this converges? No, this does not converge because this looks like a modified harmonic series. Okay, so this does not converge, and because you do not gain convergence at the point where x equals negative 1, you cannot include it in your interval. So this is going to remain strictly less than. It's not a value of x. Okay, so you go do the same test for when x equals 3. So let's go back. Let's change this to 3. So this is going to be 3 minus 1, which gives us 2 to the n. So this modification here, if we do when x equals 3, so when x equals negative 1, let's write the series does not converge. Okay, so we have to exclude x equals negative 1. We can't take it. Now, let's assume we're doing when x equals 3. So I'm going to modify this. This is the only thing you change. 3 minus 1 gives you 2. So this is going to be 2 to the n. And straight away, 2 to the n cancels 2 to the n. What you have left is negative 1 to the n over this. So I'm going to modify this. So you have negative 1 to the n. And this is gone. Okay. Do you think this series will converge? Well, this is an alternating series. Remember, a combination of alternation or the alternating property with a harmonic series always converges. Well, the terms of this are decreasing, and secondly, when you take the limit of this expression, it goes to 0, and you have an alternating negative 1 plus 1, negative 1 plus 1, it converges. So convergence is achieved at 3, but not at negative 1. Therefore, we can include 3, but we cannot include this. So this will be your answer. You can include 3, but not this. So if you want to write the answer in terms of with an interval notation, so we say the series converges. Therefore, the interval of convergence is from just after negative 1 to 3 included. This is the shape of your answer. Hope you learned something. Never stop learning, because those who stop learning have stopped living. Bye-bye.